morning, John. Can you hear me?
Yeah, I can hear you.
Okay. Now, there's just two of you right now. Are you both? Well, and now there'll be more. Good morning, Michael. Can you hear me?
Yeah.
Okay. My question is, can the three of you right now, do you see Chapter 6, the PowerPoint on the screen right now?
Yes, sir.
Yep.
Okay. This is where I'm going to start. We're going to do several things today. The first thing I'm going to do is, hopefully at least, very quickly, go over these PowerPoints. All right. Virtually everything that's in here will also be in the chapter. In fact, it will be. But I just want to quickly go over this. And if stuff doesn't make sense, I guess that what I'm going to ask is that you kind of wait until we get into the chapter. Now, I sent you two different emails today. The first one, as always, just had the URL for today's presentation. All right. But the second one had some code in it. And I was just going to go over the code, and there's a lot of it, but I decided to send it to you. So Chapter 6, which starts in your book on around page 160 or so, I don't know where it is, how to code methods and event handlers. I started to get into this subject about a week ago, where I took a program that we'd worked on and I broke it into sections and started to modularize it. Well, that's what we're going to get into in here. Plus, we're going to talk about event handlers. Some of the event handler stuff we've already discussed. Things like the click event for a button. All right, but virtually any control can have a click event that you set up for it, and there's other events as well. We'll take a look at some of that in here also. Now, I don't like to sit and read to you, but this is what the applied objectives are according to Muroc. All right. And these are the knowledge objectives. I'll leave those out there for a second. All right. Now, some of the stuff that's in here, things like here, describe the use of a tuple. I'm going to go over them. They may not make a lot of sense to you right now. To be honest with you, the first time I looked at them, they didn't make a lot of sense to me. But they're not something that you're going to have to use. Again, we're trying to get down the basics right now. All right. So they given here the basic syntax for coding and calling a method. Guess what? You know what that is. But we've always done stuff like private, and then maybe void, button, the name of the button. So like BTN underscore calculate or BTN calculate underscore click. So you've done this kind of stuff before. But again, as I mentioned to you previously, all right, what we don't want to do is put code in the actual event for the control. We want to have the control act like a driver and call routines. And if you say, well, why do we want to do that? I already gave you an example, and that is, if you remember, I think it was the, I don't know, it might have been the rock, paper, scissors program, or might have been another one. But I showed you how we could call the same routine like a clear routine, both from a button and from a menu option. All right, okay. So here's an example of a parameter of a method. The method's name is getDiscount%. It returns a decimal. So this right here is what's known as the access modifier, where I've got my mouse resting on the word private. And the two that you're going to use almost 100% of the time are private and public. Private means that this routine is only available from inside of this class, which is what basically this program. All right. If it's public, it would be accessible from other classes, so from outside of this program. And if you go, well, I don't understand public, we're going to get to that, just not until about chapter 12. The next thing that's shown in here is the type that this must return. So notice this is returning discount%, which is defined to be a decimal, and that's the return type. So access modifier, return type, name of the method, in this case it's get discount percent, then a set of parentheses. It is totally legit in that set of parentheses to have absolutely nothing, but you must have a set of parentheses. In this case, right here, in this example, we are passing in one value into this routine that's called get discount percent. We are passing in a value that's called subtotal. When we pass in a value that's also known as an argument or a parameter, but when we pass in a parameter like this, we have to let the system know the type of variable the parameter holds. So again, access modifier, return type, name of the method, and 0 or more parameters, including their name and their type. All right, I'm taking for granted as I go through this that if something does not make sense, you're going to ask. All right, so here's a method, as it says, with 3 parameters. So this method right here is called calculate future value. Again, it's private. Again, it returns a decimal. There's its name. And to do its job, it requires a decimal called monthly investment, a decimal called monthly interest rate, and an integer called months. All right, and you'll notice it returns future value, which again is a decimal, which, as I mentioned, must be that those types must be the same. All right, so for whatever reason in here, the people who have written this book, when they call a method, they're always calling it with the word this and a dot in front of it. Now, you can do that. You can say this dot and then make your method call. But in a way, it's redundant because, or superfluous, whatever you want to say, because that's basically what we're assuming anyway. It's this dot. This just is the current context. It's what's currently active, for lack of better words. So even though you can say this dot like they show here, there typically is no reason to do that. All right. So as it says there, the Intellisense for calling a method. I guess if you put the this dot in front of it, it does bring up the Intellisense, which shows you all of the different methods that you can call. So I guess if you wanted to say is there an advantage to doing it, I guess that would be it. All right. The syntax for an optional parameter. This is a little confusing. If you look up on the screen here, we've got this thing called get future value. All right, and it has in it, we are passing into it 3 parameters. One that's called monthly investment, one that's called monthly interest rate, and one that's called months. However, when we call this routine, it's only mandatory that we pass in that parameter. If we don't pass in anything else, monthly interest rate will default to 5 or 5%, and months will default to 12. So in this example, they're passing it and they're passing all 3 things in. But here they're only passing in 2. All right, so here, whatever value monthly investment was set to would be passed in, whatever value interest rate would be set to would be passed in, and whatever value months was would be passed in. Here, since we're only passing in 2, whatever value for monthly investment would be passed in, whatever value for interest rate would be passed in, but since we're not passing in months, it'll default to 12 for us automatically. Now, if that doesn't make sense to you, all right, if it doesn't make sense to you, some people like to do it like they show here. All right, and this is called passing parameters by name. So it says, hey, monthly investment will be called monthly investment and months will be months. And you might look at that and go, okay, I get it, but why the heck would you do that? If we left this off, if we only passed in 2 parameters here, if we only passed in 2 parameters. So if this just said monthly investment here like this and months, all right, it would think that monthly investment was the first parameter and months was the second parameter. So it would think that was actually the interest rate, all right, which would be wrong because it would be 12. All right, now what I'm saying may not make a lot of sense to you. And if it doesn't, I strongly suggest that you take a look at the chapter in the book. All right, I'm just going over the same examples that they have in there. All right. This method right here that's called display error message only displays a single line of code. You've already seen, I'm not going to jump out of here right now, but you've seen, for example, in our exit routine, all right, we put in several lines of code. So one method can have really one or more lines that execute inside of it. Totally fine. Now, what they're saying here, and this is a little hard to read probably and fathom, this right here is the same thing as saying this right here. So what do I mean? All right. Technically, this here, what you see right here is 1, 2, 3, 4 lines of code. Putting it like this, technically, even though they put it over 2 lines, it's 1 line of code. All right. So this, it says with an expression body, this is considered a shortcut way, this, of writing what's up here. Now, not for you so much, Johnny, but for Michael and for Donald, last semester, you may or may not remember, but towards the end of the section on JavaScript, we talked about arrow functions. And that pretty much is what this is right here. The name is different, but the idea is very similar. All right. Okay. Then they're showing you some more shortcuts here. And you look at this, and this might confuse the heck out of you. If it does, I'm sorry. What they're saying here is if the customer type is R, all right, then we are setting the discount percent to 10%. If it's C, we're setting it to 20%. If it's T, we're setting it to 40%. And if there's nothing specified, we're setting it to 0%. So this is a special thing. This is an underscore. It's not a minus sign. So what they have right here, we could have written as the way we've been doing it, and that would have been to say switch on customer type. Then we would have said if it's R, then underneath it, we would have said discount percent equal 0.1 M and then a break. So this is a shortcut way of writing what we have done previously. And you can do it like this. All right, and you can do it like this. Either one of these ways will work. All right, and if you go, you know what, that's really confusing, then don't do it. Totally fine not to do it. What they're showing you in here, this book is trying to take you from a novice to somebody who's, let's just say, well, if we looked at it as going from novice to maybe beginner to intermediate to professional, they're trying to bring you up to at least an intermediate level here. So they've shown you different ways of doing things, and now they're trying to show you what they consider to be shortcuts of doing the same thing. All right. So let's see, what do we have here? So here we've got our button click event, and we're doing all the code right inside of the button click event. All right. What we're going to start doing is pulling that code out of the button click event and putting everything that's in here into one or more of its own methods. Now, and again, I may have mentioned this to you before, I may not have, but imagine in this case where we've got the calculate button, the click event, let's just pretend for a moment that there's 1,000 lines of code that go inside of this click routine. You would not write 1,000 lines of code inside of a click routine. it would be very hard to debug something like that. But let's imagine in these 1,000 lines of code, let's say there were 50 different things that you wanted to do. Then what you would end up doing in this calculate click routine is you would call 50 different methods from within there. Now, you're not typically going to have 1,000 lines of code. But what I'm telling you is in here where we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines of code, we might very well break this up into 2 or 3 different methods that we would call from right here. And that's what I'm trying to get across to you. All right. When you do this kind of stuff, your code, at least in your click routine, is going to look cleaner. You're going to see that. We're going to look at that in just a couple minutes. All right. Okay. So let's see. It says the method added to a class. Yeah, again, we're just going to make it easier. Now, what you can do, and this is going to be confusing, so if you try it and it doesn't work, then just try it on an example, and if it doesn't work, don't use it. What they're telling you can do here is, again, let's assume for a minute that we had written something like this. So we've got a click routine that's got a bunch of code in it, and we're thinking this click routine is getting too big. Well, what they're saying here is what you can do is you can select the code you want to create a new method from. So like put it in yellow like we've got right here, and then press Control plus the period, and it'll bring up what's called a quick actions menu. And if you select extract method, what it'll do is it'll pull that code out and it'll put it in its own method. Now, it'll call the method new method, so you'll have to change the name, but that's what's known as refactoring. Typically, when you refactor, again, I've always gone to this kind of example, and maybe it's not the best one, but it's like when you are writing an outline and you've got a bunch of stuff. So you've got Roman numeral 1, and underneath that, you've got an A. And A has got numbers 1, 2, 3, 4, 5, 10 different numbers in it. And you decide number 1, wow, that's too big. So you want to break number 1 up into 1A, 1B, 1C, and 1D. That's kind of what you'd be doing right here. And again, if you find that confusing, for now at least, just ignore it and don't worry about it. All right. I think I've mentioned this to you before, but in case I have not. All right. And again, this will make much more sense when we look at some examples in just a little bit. Okay. But if I write some code, and let's say that I write some code and I pass 2 parameters into a routine. All right. Or 3 like we've done here. I guess there's 4. So we've got decimal monthly investment, decimal monthly interest rate, int months, and then a decimal called future value with the word ref in front of it. What does that mean? When I pass in these first 3 values, monthly investment, interest rate, and months, when I pass those into a routine, what the system does is it says, okay, whatever call this, make a copy of monthly investment, make a copy of interest rate, and make a copy of months, and pass those variables in to this routine. They're just copies. This, by putting the word ref in front of it, it says, I don't want a copy of the variable. I want the actual address in memory where the variable lives. And you might say, well, what's the big difference? The big difference is this, all right? Since these are copies, if we were to change monthly investment and or monthly interest rate and or months, if we changed it in here, we shouldn't, but if we did, we're just changing a copy. The original values don't change. But with future values, since we're passing in as a ref, anytime future value appears on the left-hand side of an equal sign, it is a permanent change. All right, that's the big difference between these. And again, You're going to keep seeing this over and over again. If you use it as a ref right here, inside of the method itself, you have to also pass it as a ref. All right? So when you use it as a ref, you pass it as a ref. Okay? You'll notice there's two other things in here, an out and an in. An out means if an out parameter gets set inside of here. So in other words, it's write only. An in means it's read only. That's the default. It means that you can't change it. Here you must change it. And again, this might not make a whole heck of a lot of sense. All right, we're in chapter 6 now, and the stuff is going to start getting a little bit more complex from now on. All right, so there's an out right there, and it's got future values. So this will make a permanent change because it's an out parameter. What's the difference between an out parameter and a ref parameter? All right, the ref parameter could have had a value in it previously. The out parameter shouldn't have a value in it previously. All right. All right. And there's different ways that you can do this. Okay. Finally, there's an in parameter. This is pretty new. And as it says here, you're passing these in as in parameters. I don't see the advantage to doing this, so I'm just not going to talk about it anymore. All right. Now, you may have found that hard to understand, but believe it or not, that was the easy part. Because the next few pages, if you find these next few slides confusing, forget they even exist for right now, okay? What has happened in the last few versions of C# is they've allowed you to use what are called tuples, all right? And if you go, well, what the heck is a tuple? Well, when C# is one of the many programming languages that is used to work with databases, all right? And in databases typically are filled with tables, and tables are filled with records. What do I mean? Well, my class, if you looked at my class that you're in right now as being, let's just say we had a table that had the name of the class, which was C# Programming Fundamentals or something like that, the number of the class, which was AWD1100, and it had that information, and then the records in the class would have been Donald Waters, and then your rank and ID number, and John Stark with your rank and ID number, and Michael McLean, etc., with your rank and ID number. All of that individual information, they would be referred to as records about you. Records are also known as tuples. Now, so who cares? Well, what's kind of cool about these is when you work with a tuple, you can put a lot of information in here. They're only putting in two things. All right, item 1 here and item 2. But there could have been 50 things. Let's just say a first name, then a last name, then an address, then a city, then a state, then a zip, then a phone number, etc. So you could have a whole bunch of things in here. All right. Now, it makes it ugly when you have to do this, because then you have to give everything a name, basically. But where it's kind of nice is when you use it in here, it'll make your program more self-documenting. All right. And if you go, hey, that just totally confused the heck out of me, then for now, pretend it doesn't even exist. With all the program examples that we're going to go over today, and there will be several. All right. We're going to just pretend it doesn't even exist. All right. So like I said, I'll just hold off on the tuple stuff for now. Okay. Believe it or not, we're almost done with these slides. We're on slide 27, and I believe there's 37. Yep. So we got about 10 slides to go. So give me about 5 to 10 minutes and we'll finish this up. The event list for a text box control. Guess what? You've seen this. I've already shown you where if you look on the screen here, where we go in and we click that lightning bolt, and it shows all of the different events for whatever control you've listed. So I mentioned if you accidentally double click on the text box and it's got the change event, you're like, oh, I didn't mean to have that there. How do I get rid of it? And as I said, you would come over, click on the lightning bolt, find that changed event, highlight it and hit delete, and it'll be gone. All right, so any reference to any code is gone. We've done this where we double click on a button and boom, then this would say something like BTN calculate, and this over here would say click. So you've looked at this kind of stuff already. Every single control has a default event associated with it. I want to say that again. Every single control that you put into your program has an event associated with it. And if it's a GUI program, even the form has a default event associated with it. With a form, it's the load event. With a button, it's the click event. With a text box, it's the text change event. So if I had a text box that asked me for my first name, and it says, give your complete first name. So I don't want to put Jeff in there. I want to put in Jeffrey. So I type in Jeffrey, 7 letters. That would mean in that text box, I would have seven different text changed events that would take place. Why is that important? Eventually, we're going to set it up so that if we've got a field that's supposed to hold numbers, if you try to put something non-numeric into it, if you try to type something into it that's not numeric, it won't accept it. All right, so we'll go and look into the text changed event in more detail later on. All right, this wiring that they talk about, this is what happens behind the scenes. So when you double click on a text box, you bring up that text box's text change event. And a line of code like this gets added to your designer file. And that's what they're saying here. All right. So you can put code in there rather if you want to or need to do so. And that's what they're saying here. All right. So how to select an existing event handler? Let's pretend for a moment in this particular text box, this interest rate, that we wanted to put something into this thing here that said tab index changed. Well, we could click on it to make it active. Oops, we could click on it to make it active, then we could go over to the lightning bolt here and click on it where it says whatever one we chose, text align changed or whatever it is. But notice here with this text changed, if we click the down arrow, we get all of the code that we have named. So in other words, it says here for text changed, what do we want to do right here? Well, what this says is if the text changes, we want to call clear future value event. And again, this might not make a lot of sense right now. It should make more sense as we keep going in here. This again is what's happening behind the scenes when we do this. All right, kind of stepping you through it, but it's going to go and make changes for you into some of your system files. All right, the last thing that's in here then is they go back over this future values thing. And notice now where we've got this future value, they have gone in and they have written their own event for doing that. So notice what happens is the exit button gets small, the clear future value button gets small, etc. The idea is, as I told you, we do not want to put a lot of executable code inside of the events for a control. Ideally, we want to put in nothing. All right, and you're going to see that in just a couple moments. Again, this is what's happening behind the scenes, so I'm not going to go over that. All right, so is this. All right, we're going to build something, or I have, and we're going to bring it up, that looks similar to this. Is it exactly the same? Mine says number 1. I think this says operator. This says number 2. This says result, and we've got to calculate a clear and an exit button. So you're going to see all those in just a couple minutes. We're also going to go back and it says we'll add a method to it to make it do something. So we'll do some of that stuff. All right, so let me close this. And in fact, rather than closing it, let me come back over to here, go to here, and I'm going to stop sharing for just a second, start sharing again. And now I want to go, let's see, over to here. All righty. So my question for you is right now, can you see page where I've got my mouse right here, where this says 163 right there? Can you all see this? Yes or no?
Yes.
Okay.
Yes.
So now I want to start going over chapter 6 in the book. So in other words, when we went over chapter 6 in the PowerPoints just a couple minutes ago, that was what I like to refer to as the airplane view. In other words, we're looking at this from a real high level from 35,000 feet. Now we're getting lower. You know, if you're ever in an airplane and you're up real high, you can make out certain things, but if you're up high enough, you can't tell where houses start and end, etc. Well, when you come down lower, you can. So now we're coming down lower and we're going to look at this in more depth and breadth of coverage. All right. It says so far you've been writing methods called event handlers for click events. And that's about it. In this chapter, we're going to talk about how you can do it as it says for other methods. All right. It'll help you logically divide your code into more manageable parts. Again, this is also known as modularization. And it says you'll also learn how to code event handlers for things other than a click event. That's what we just talked about. So we're going to spend the most time on this. Quickly, again, go over the tuples. This events and delegates rather, probably won't make a lot of sense and probably didn't, but most of it happens behind the scenes. And when we get to chapter 12, which won't be for like about another month or so, then this stuff will hopefully make a little bit more sense. Finally, as it says, we'll look at that other version of future value. All right. So I'm going to spend most of my time on the pages on the right. So I'm on page 165 here. And again, they've got public and private. There are actually a few others that you can use. But as I mentioned, probably for much more than 99% of the time, your methods will either be public or they will be private. And again, if they are public, not only are they available in this program, but other programs can use them as well. If they're private, they're only known within the class that this program is. So their scope is what it's referred to. If it's public, kind of look at it as, and I know that doesn't work like this, but technically, I should be able to go, for example, to, I don't know, let's just say to President Biden. Since he's a public figure, I should be able to go and call him up and say, hey, Joe, this is Jeff Scott. I'm a teacher at Rankin Technical College, and I've got some issues with some of the stuff that's going on in this country. And I should be able to set up a meeting with him. Or really, you know, I know it's not like this anymore because of security reasons, but I should be able to just show up at the White House and say, hey, I want to see the big guy. I know it doesn't work like that, but that's typically with a public figure, meaning everybody should have access to them. All right. On the other hand, if somebody comes and rings my doorbell and I open up the door and they walk in and they go, well, I wanted to have lunch with you. That's a little different because I'm a private figure. I am public in that I work for a public institution, but basically I'm private. Now that's not the greatest of analogies, but it's the one I usually give. All right. The majority of the stuff we've done so far for methods has been private. The majority of the stuff we do for methods will stay private. All right. But rather than putting something inside of a buttons click event, we're going to have that button click event. So if this was it here, instead of putting in these two lines of code, we're going to have this buttons click event is going to call disable buttons. and that's where the work will be done. All right. So what we're doing is, for lack of better words, we're kind of segregating the work into different units and writing different methods, a different method to handle each unit of work. All right. Here is a method with no parameters, but it still needs the parens. Here's a method with one parameter. Here's a method with several parameters. All right. I'm not going to sit and read this to you. All right. The key takeaway from what's down here, though, is if this method says private void, you don't need a return statement. But if it says private with something that's not void, like decimal, you must have a return in it, and that return must be of type, in this case, decimal. All right. This whole thing that's in here, basically this whole thing, private, decimal, calculate future value, this, all this stuff, it's referred to as the method signature. All right, that'll become more important again when we get to about chapter 12. All right, so how do you call a method? You just give it the method name. Again, you can say this dot, and it'll bring up the Intellisense as we talked about before, or you can just type in the method name. And that's what they're saying in here. All right, when you pass different things to a method, by default, they're passed by position. What does that mean? That means that if in here, I'm going to pretend for a second, our monthly investment was $10,000. No, let's just make it $100. So I'm going to pretend our monthly investment is $100, and we're going to pretend, just for lack of better words, that our interest rate is 100%. If we flip these, so when we pass them, if we put right there, if we put 1 for 100%, and we put right here, instead of 1, we put 100, it would think our monthly investment is $1 and our interest rate is 10,000%. All I'm telling you is, when we call a routine and we pass in 3 values, it says whatever value you passed in first is this one, whatever value you passed in second was this one, whatever value you passed in third was this one. So that's called passing it by position. All right. And that's basically what they talk about in here. All right. The optional ones we talked about, mentioned it before. So here we have 1 required parameter, monthly investment, and 2 optional parameters, monthly interest rate and months. So when we call this, there's different ways that we can call this thing, and that's what they're showing in here. Here we're passing in all 3 things. So the first one is monthly investment, the second one is monthly interest rate, the third one is months. In the next example, we're only passing in 2 things. So again, the first one is the monthly investment, the second one is the monthly interest rate. Since we didn't pass in a third parameter, it gets that default that you see right here in gray. So in other words, it's going to get a default of 12. Finally, if we only passed in 1 parameter, and they don't show that example here, so if we only passed in monthly investment, that would be the first parameter. It would default to 5% for the interest rate. It would default to 12 for the months. And again, I've had people say to me, okay, you know what? I get this. I understand it. Why the hell would I care about it? Why would I want to use it? All right. Well, notice for months right there, if we're assuming there's 12 months in a year, which is a pretty good assumption, that would be a good thing to put in there as a default parameter. But let's make it simpler. Let's suppose that I work for Rankin, and I'm employed. I'm supposed to set up something for the Rankin St. Louis campus. And let's also suppose rather, just for lack of argument, that 75% of the people who go to Rankin St. Louis campus are from St. Louis and, of course, then from Missouri. Well, if I was going to pass in city and state there, I could say, for example, string city equals, then in double quotes, I'd put St. Louis, comma, string state equals, and then in quotes, MO. So there are times when having default parameters makes it easier because there's less code that you have to worry about when you're passing things in. Now, I would strongly suggest that if you're ever going to use optional parameters like that, that you name them the way that we looked at that and the way that they show in the example on your screen right here. Now, do you have to do that? No. But it makes it much easier when you are doing it. It makes your code more self-documenting. All right. And that's one of the things you should always be shooting for, is to make things more self-documenting. All right. Why? Because most people don't write nearly the comments they should write in code. All right. So again, here's an example of a method that just has one line of text in it. And we could have multiple lines of text in it. And again, you can write it like this, or we can use this expression body. They don't call it an arrow function like, gentlemen, like we did in the Java script portion of the AWD1100 class last semester. And John, you'll learn this in fall of next year. But it's a shortcut. Just in the same way, instead of writing switch statements as we've written them, you can use one of these. And they're shortcuts. And again, you'll notice that and I can't remember the doggone name of this right here. Let me see. I don't want a double underscore. Is this a valid identifier? It's in your book. I just don't know where it is in the book, but there is actually a name for that. All right, the underscore. All right, I don't want to get too hung up on that, so let me go back to here. All right. In fact, let's quickly look. Just see, did it show it in here? All right, well, it does in there someplace. I remember reading it, I just don't remember what it was called. The refactoring is what I'd shown you. So again, they're going to highlight all of this code right here. After they highlight it, they're going to do a control plus a period to bring up this extract method. It's basically, it's like when you right mouse click and you bring up a menu here. I'm not getting one, but hopefully you know what I'm talking about, like a little quick menu. And it'll automatically try to do some refactoring for you. The good news is it'll do that. The bad news is it'll call it new method, so you've got to remember to go in and change it. All right. Reference and value, I've already hit on those with you. And again, I'm going to show you some examples of that stuff in just a bit. All right. So ref is short for reference, and ref means that instead of passing in a copy, you pass in the address of where this lives in memory. So any change you make with a ref is a permanent change. With an out parameter, it's like write only, which means that the value is going to be set inside of the value will be set inside of the method in return. In is kind of the opposite. It's more or less read only. All right, let me double check. All right, I'm cool. There we go. So again, there's the out. Now notice it says C# 6.0 and later. Well, we're running, I believe, 11. So this has been around for a bit. I'd say a good 5 or more years. And there are examples. We'll take a look at some of this stuff a little bit later. That's what it's called. That underscore is called the discard character. All right. And basically, when we just looked at the discard inside of a switch statement, discard is just a shortcut for you using the word default in that case. All right. I'm going to skip the tuple stuff. Like I said, it's a little bit complex to work with right now. Take a look at it. If you're interested, we can talk about it, etc. not a problem. All right, how to work with events and delegates. As it says here, back in Chapter 3, we learned how to generate the event default, or the event handler rather, for the default control by double-clicking on it. It says now you learn how to create it for any form or control event. As I said, anything that goes into a form, the form itself, and anything you put into it. So what have we talked about so far? All right, so far we've looked at, I'm just going to give you some examples. We've looked at labels, we've looked at text boxes, we've looked at buttons, and that's been the majority of what we've done in virtually every program thus far. We're going to look at another one today, which is called a combo box. And if you say, what's that? We're going to see it in just a bit. But with any of those controls, if you double click on the control, you get the default event for the control. But as you've seen, when you come over here and click that lightning bolt in your properties window, when you click the lightning bolt in your properties window, what ends up happening, all right, what ends up happening is you show all of the different events, all right? And I just cringed right now, just so you know, and the reason is I said I was going to put this both on the YouTube channel and I was going to put it in Teams. I am recording in Teams. I forgot to turn on Camtasia. So I'm just going to copy this one over to my YouTube channel. So sorry. All right. So wiring, again, when you go and you double click on an event. So if I come in here and I double click right here on text changed. So if I double click on that text box, it brings up the default event, which is text changed. If I want to put in code for another event, then I have to click the lightning bolt, choose the event I want. All right, and then I can put in code for it. And that's what they're basically showing right here. So what happens when you do this, if I double click on a text box, it brings up the text changed event. Now you might look at this and go, okay, well, what are these things? The sender is basically you. The sender is what caused the event to happen. And the arguments are any arguments that the method needs to do its thing. Now, the event args, most often event args are used with things like mouse. Like if you were writing a program that was going to allow the mouse to move on the screen, maybe you were writing a game. Then your arguments might be the current X position of the mouse and the current Y position of the mouse as examples. All right. You're going to get the most out of this if you go back and you read, look at what's on the right-hand side of the page, of the 2 pages, and then look at the examples and then read the description down below. I'm just trying to summarize it, that's all. All right. So again, and what they're not showing here, what they're not showing, and I want to mention this to you because it's important. Let's assume that for whatever reason, and even if it doesn't make sense, just bear with me for a second. But let's assume that when you clicked any one of these 4 text boxes here, it doesn't matter which one, but you want the same routine to handle all of them. When I double click that one, I want the same routine to run. Then what I can do is I can double click the first one and give it a name, a generic name like handle text box. Then for this one, I can go in and find the text changed event. And when I hit the down arrow, it'll show handle text box in here. So what I'm telling you is if you want multiple controls to respond in the exact same way, then rather than writing 4 different, and you can do it that way too, writing 4 different calls inside of a text changed event, what we're basically doing is the same thing by coming in here and for each one of these, hitting the down arrow and choosing the same routine for all of them. And again, if it doesn't make sense, don't worry about it. All right. All right. Finally, the future value. All right. And this generated code is, again, what happened when they broke this up and tried to write it into its own routine. And that's what they're showing in here. All right. That's pretty much it. Now, I said I was going to bounce back and forth, but I figured it would be simpler to do it this way. Now, what I'm going to do is, and I've given you all this code except for the one I'm going to very quickly try to write in 5 minutes. All right, so the code that I'm going to bring up right now, I gave it to you in a zip file. You've got this zip file, and unfortunately I gave it the name calculator. And it's not that calculator is a bad name, but I put a few non-calculator programs in here. So we've got calculator console 0, calculator console 1, calculator GUI 2 and GUI 3. I don't know what happened to 1, but MPG console and MPG GUI. So you've got 1, 2, 3, 4, 5, 6 different things in here. And I'm going to very quickly add another one. All right. So the first thing I'm going to do is I'm going to steal my code that I put in here. And if you go Y, you're going to understand this, hopefully at least.
Mr. Chad?
Yeah, I'll change it. I'll change it in just a minute. Thank you.
Okay.
I'll change my window in just a second. All right. So let me do that right now. All right. Can you now see my code?
Yeah.
Okay. So I'm going to quickly come into this solution and I'm going to say add new project. And it will be a console app. And I'm going to call this, the other ones I called, what was it? Calculator console. And I've got calculator console right now, 0 and 1. I'm going to make this 0, 0. This is going to be real fast. I'm going to do this and then we're taking our break. All right, so create this. There it is. Now I'm going to come in here and I'm going to paste in all of this code. It may give me an error message if my paste was bad. That's okay. I don't need this, but I do need my import. I'm sorry, not import, using static system.console. Hopefully that'll get rid of, yeah, got rid of all my errors. Okay, you have written programs like this. I'm doing this real fast. All right, and that is, we've come in here and you've written programs where, let's see, I've got these 3 variables. I'm going to get rid of everything that's inside of main for right now, everything that's in here. And I'm going to see if I can replicate it literally in about 5 minutes. All right, that's a pretty big task, but I think we can all do it. So I'm going to come in here. In fact, I'm going to take these variables and I'm going to make them all local. So I'm going to put everything inside of main. This is the kind of stuff that we've been doing. Since they're in main, you don't put the word static in there. So we've done stuff like this before where we've said this, right? Input number 1. And then we've said num1 equals convert dot toInt32 read line. All right, again, you've done this before. And then we've come in and done the same thing. But we've inputted number 2. All right, and did num2 equals convert to int32 read line. Then we're going to say input operation. And we'll put in here plus or minus or multiply or divide or modulo. And where is it? Modulo. All right, so one of those. All right, and then we come in here and we say operation equals this. And it's going to just be read line because it's a string already. All right, so we've got all that. Now, what you see on your screen right now should not confuse anybody. We've done stuff like this before. All right, now I'm going to come in here and I'm going to say, I'm just going to do quickly. I'm going to make a bunch more variables. So I'm going to say here, int sum, int diff, int prod, int quote for quotient, int mod. Right, so I just made those variables. And I'm going to come in here and say sum equals num1 plus num2. And I'm just going to copy this. I'm going to put in here right line. The sum is sum dot toString. Okay, again, you've done all this stuff before. So let me quickly copy this. All right, so there's sum. Then we'll do diff. That equals num1 minus num2. And it'll say here, oops, what I did there. So there's the sum, this is diff. So that's a minus. And we're going to say here the difference is, and that'll be diff. And this will be prod for product. And this will be num1 times num2. And here we'll say the product is, and that'll be prod. Come on. All right. This will be quote for the quotient. And that'll be a divide sign. And we'll say the quotient is, and that'll be quote. And finally, we're going to say mod, and that'll be the modulus operator. All right, and we're going to say the mod is. And we'll put mod in here. And so our program doesn't go nuts, we'll just put in a read line here. And I'm going to save this and run it. We're going to take a break in just a moment. All right, so I'm going to set that as my startup project, and I'm going to put this in and run the program now. So it says input number 1, and I'm making these up. The numbers mean nothing. 59. Input number 2, 13. Input operation, well, you can see it. So I'm going to just put in here, I didn't even need this now, but I'll just put in a plus sign. All right. So the sum is, so 59 plus 13 is 72. 59 minus 13 is 46. 59 times 13 is 767. 59 divided by 13 is 4 with a remainder of 7. Now I'm asking real quick, does that all make sense to everybody?
Yeah, I believe your application isn't pulling up again for whatever reason.
Okay, and I don't know why I don't know why that's happening, but you'll have to take my word for it. What I will do is I will send you this file during the break. All right, and if you want, you can bring it up yourselves. You don't have to, but if you want to, you can. But I want to show you, for lack of better words, some of the foibles or some of the problems with doing this. In fact, let me bring this up. Let me fix it real quick first. So that's got to be parenthesis and then this space. Okay, and let's see. All right, be enough. So let me go over to here and to here, and let me stop my share, start my share again, see if I can bring in. All right, now can you see it on the screen?
Yes.
Okay. All right. So don't worry if you don't see it. You will in just a second. All right. Can you see it again on the screen where it says input number 1? Can you see that?
No. Now it just shows everyone in the meeting
because of the way that I screwed with that thing. So let's see. Try it again. All right. Now can you see it on the screen? Input number 1.
Yes.
All right. So I'll put in here 13 and 4. Now, I really don't need to input an operation, but it's fine. I can pick any of these I want. In fact, I can pick anything. I can even leave it blank. So the sum, so 13 plus 4, 13 minus 4, 13 times 4, 13 divided by 4 with that remainder. Can everybody see that? Yes?
Yep.
Okay. After the break, we're going to take this and we're going to break it down and start modularizing it. All right. It is now 9:05, and I realize that it probably left on your screen, but we're going to go back to here. And to here. All right. And I'm going to put up my 10-minute timer, not 20, 10-minute timer. All right, your break has begun. I'll be right back. I'm going to refill my water. All right, I'm back. Hopefully you are as well, and I'm going to continue on. All right, so what I want to do here, and I guess I'm going to have to keep switching back and forth here on my view, but that's what I'm going to do then. So I'm going to go stop my sharing here, and I'm going to start my sharing on Visual Studio. Can you now see Visual Studio code? Or Visual Studio, I mean. Can you now see that?
Yes.
Okay. Now this thing that's here, I really didn't need a simple example. So I can take this and I can just comment that out. Now, I don't need an operation, so I can comment that out. And the program will still work just fine. All right, I can also comment out these two lines. What I'm doing here, simply, when you think about it, if you remember, one of the things that I showed you a lot earlier this semester was how we can go in there and we can write one of these IPO charts. I'm going to make this real simple. I'm going to have inputs, processing, and outputs. Right? And again, you've seen this kind of thing before, but I don't want to insult anyone's intelligence. But if I said, well, what are our inputs? Well, number 1 and number 2. Those are going to be what we're inputting into the system. Well, then what is our actual processing then? Well, we want to input in number 1, then we want to input in number 2. In a true calculator then, we also want to input in the operation, and then we want to calculate result, and finally we want to output result. So our outputs here, the output is going to be result. Now, I'm not trying to insult anyone's intelligence, but I want to ask the question, does all that make sense? We're assuming the world's simplest calculator that will take two numbers and either add them up, subtract the second from the first, multiply them, divide the first by the second, or divide the first by the second and give the remainder. Does that make sense to everyone? If I hear nothing back right now, I'll assume it does. All right. So that's it in about its most simple format. So let's talk about the problems with this in its most simple format. And guess what? You already know a lot of this, even if you think you don't. What do I mean? I'm going to run the program and I'm going to have to switch again. So I'm going to run the program and I'm going to come back in here then, and I'm going to switch. I wonder if I do this. You guys will have to tell me if this will work. I'm going to change it to screen instead of window. All right. Can you now see everything? Can you see back? Can you see my code back here and the run? Can you see them both?
Yeah, we see them both now.
All right, then hopefully this will work. So if I come through here and I just put in hello and I hit enter, what's going to happen? Can somebody tell me? Anybody want to take a guess?
It'll still output your, all the outputs for all your operations.
Okay, I'm going to guess the program's going to blow up right here. Let's see. And it did. And it says input string was not in the correct format. Remember those? The reason is, and I appreciate the guess, I really do. The reason that it blows up is right here. It's attempting to take nothing, which is what I put into the read line, and convert it into an integer. That fails. I mean, I put hello in there, I guess. If I'd have put nothing, the same thing would have happened. So this program, the way it is, works fine as long as I do put in a number here, and I do put in a number here, and hit enter. Now it's cool. Can you see all that? So can you see the result and my screen up here? Can you see all that? Yes?
Yes, we can see it.
Okay.
Yes,
All
sir.
right. Okay. So the problem with it in its current format is we're not doing any validation. All right. So the reason I'm telling you that is what we could do is we could change this a little bit. What do I mean? I want to show you right now. Hit enter here. And I'm going to put in here validate number 1. All right. Then input number 2 and then validate number 2. Then input an operation, we're going to add that, and then validate the operation. Finally then, if everything works, then we'll calculate and output the result. So the difference is what we're bringing in here, we've done some of this already, but we're saying, hey, we don't want this program to blow up. All right, so in other words, when we look at the next iteration of this, which is what we're going to do in just a minute, we don't want the program to blow up. Does that make sense to everybody? Yes? Okay.
Yep.
Okay. So we're going to look at 2 different versions of this. With the first one, we're going to replicate and we're going to write one routine to do this and one routine to do this, even though it's the same code. So we're going to write one routine to do this and another one to do this. And we're going to put the same code in each one. So let me do a file, save all. All right. And let me come back, and I don't remember which one of these this is, so I'm going to look. Yes, this is the one. All right. Can you now see on the screen where it says calculator console right here? Can everybody see that?
Yep.
Okay.
Sure.
So if I run this one, all right, notice the difference. So I'm going to run it here. Hopefully you can see the run and everything. If I hit enter, well, it's still breaking. It's still broken. All right. But what have we done? Well, let's take a look and see what we've done, and we'll fix it in the next one, I guess. But in here, what are we doing? Well, we're coming in here and we've got num1, num2. In fact, I think is this the same one I just brought up? Oh, that's fine. So we're going to come in here. Yeah, this is the one I just had up. So let me get the next one. That's the one we want. Okay. So I didn't set that as my start project, which I want to do. There we go. Now let me run it. All right. So I'm running it. Input first number. I'm putting in hello again. And what happened? Well, it's hanging. It's actually good news and not bad news. It's hanging, but it didn't break and stop. All right, we're going to fix that in just a minute. But what I want to show you is this. First of all, if you look at this line right here that's in blue on your screen, that is an infinite loop. I'm not asking you this question. It's basically, but does everybody know that 1 always equals 1? All right, you do, right? So this is going to put this into an infinite loop. But what am I doing here? Rather than doing everything inside of main, I'm calling clear. Then I'm telling it to input my first number. Then I'm telling it to input the operation. Then I'm telling it to input my second number. Then I'm telling it to perform the operation. All right. And I even could have put another one in here. We can put that in that says display outputs. I don't know. Display output. Now it'll give me an error because I didn't write that, but you get the idea. So I can come down to the bottom here. And in the very bottom, I can put in here private, I think I need static, void, display output. I won't put anything in there for right now. I just want this to not break. All right. But what I'm trying to show you here is modularization. So we've got here input num1. Let's take a look at that. What does it do? All I did was I pulled out those 2 lines of code that we had in there. We're still not validating. We'll do that in the next iteration. All right. So let's say I put in 15. So where it says input first num, I put in 15. Num1 is now equal to 15. It works because you can do the conversion. Then I say input operation. So it's going to come in here and it's going to write this input message that says enter operation, plus, minus, multiply, divide, or modulo. So it'll say that on the screen. And again, as long as I put in one of those, I'm fine. This is checking to make sure that I put in one of those. All right. And if I did, it's going to say illegal operation, try again. This one I put into a loop. So notice if I run this program and I put in here 15, and now I put in hello. See that? Illegal operation. You can see we're already getting some validation in there. How about a comma? Nope. How about nothing? Nope. How about a plus sign? Yep. Now this will still break if I put in hello here. So I'm not going to. I'll just put in 2. And now I get 15 plus 2 equals 17. So that worked. Good. All right. So what I'm trying to tell you is we're starting to put in validation. So we input our first number, then we input our operation, then we input our second number. But what I want you to get is this right here, this is exactly the same. In fact, let me collapse this one. Oh, it is right here. As this. These two are the same thing, except for what? This says a 2, this says a 1, this says second num, this says first num. The point is, the logic in these two things is identical. So what we'll do in just a minute is we'll break that into one routine. All right? Sometimes we may end up even writing a little more code. Sometimes you end up writing more code to make your program more intuitive. And that sounds like a non-intuitive statement. And what I mean is, I'm saying is sometimes you've got to write more code so that people who are looking at your code, so it makes more sense to them. All right, like I said, that may sound like a non-intuitive type of statement, but that's the way it is. So we've called input num1, we've called input operation, we call perform operation, or input num2, and then we call perform operation. Well, what's that doing? All right, that says, hey, notice what we're doing in here. In this switch, we're calling routines. So calculate and display sum. That's what it called when I put in the 15 and the 2. What did that do? Well, notice what it is. All right. It's only handling the sum. It's only handling the difference. Only handling the product. Only handling, in fact, no, this one is not. When I'm doing the quotient and when I'm doing the modulo, both of them are going to attempt to do a divide. I'm not asking you, I'm telling you. What we don't want to do is try to divide by 0. So what I'm saying is if we attempt to divide by 0 here, just put a message out that says illegal attempt to divide by 0 and get the heck out. Then notice I've got val equal 1 here and I've got val equal 2. What does that mean? Well, if what I passed into here is a 1, I want to do a divide. And if what I passed in here is a 2, I want to do a modulo. So notice that when I call these routines, it's called calculate and display quotient or modulo. So when I pass in a 1, it's when I did the divide. And when I pass in a 2, it's when I did the modulo. So you'll notice that if I run this now, and let's put in 15 and 2, I'll put in a divide. First, let's try it with 0. Illegal operation, try again. So it's handling that. Now I'll put in a 2. All right, whoop, not a 2, a divide rather, my fault. And it says enter second number, a 2. And I get 7.5 because I actually made them both doubles. So I'd get that portion. All right, but it's actually 7 with a remainder of 1. So let's try it again, 15 modulo. and 2, and I get 1. Good, it works. What I'm trying to get across to you right here is what we have done now is we took our original program, all right, and we taken main and made main what it's supposed to be. We really don't need this display output. I'm going to get rid of that. All right. So let me get rid of it down here as well because we didn't need it. All right. So what we've done with main is we've made main a driver. Initially, we threw everything inside of main. In the example I went over with you before the break, we took everything, all right, everything that was there, and we put it inside of main, all right? Main really should be what's typically referred to as a program driver. Now, I am putting an infinite loop here in these lines and this line, but what is main doing? Calling a method, 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 calling a method. All right. Why is that important? Now I'll know if I've got a problem inputting my first number. Let's just say I do. I know it's got to be in these lines of code right here. If I have a problem inputting my second number, I know it's got to be in these lines of code right here. If I've got a problem inputting my operation, then I know it's got to be in these lines of code that are right here. Finally, if I've got a problem performing my operation, well, it's a little more difficult because it could be in here, but it could be in one of these that I'm calling. But the point is, even this routine right here is not real long. It's about 20 to 25 lines. And all of these routines are very short. All right. So really what an object-oriented language like C#, all right, what we want to do is, if, as an example, if we have a program that's got 100 lines in it, I know this one's probably got more than that. It does. All right, so 136 lines. So rather than writing main with 100 lines in it, we write main that calls this, and this is just a single line. That's about 4 or 5 lines. That's about 10 lines. That's 4 or 5 lines. That's about 25 lines, and that's 1 line. So we're breaking it up. So if for some reason, let's just pretend for a minute that each one of these routines, those are the ones in blue that we're writing, let's assume that each one of those routines averaged about, let's just say 100 lines of code, and they were pretty complex. So let's suppose for a minute that this is some kind of a tax rate program. All right, and these will be different tax rates or whatever, it doesn't matter. The point is, what we can do now is we can have 4 different people write those routines. That's one of the reasons that you modularize, because in most companies of any size, you don't have just one programmer. You've got a whole programming department, a programming team, or whatever it is, and each one of them is responsible for their piece of the pie, so to speak. All right, so this is better, but it's still not great because for 2 reasons. Number one, we're still doing the convert, so we're not accounting for it. So if that doesn't work, we're hosed. That's the first problem. And the second problem is this routine and this routine are virtually the same thing. So we're going to attempt to fix that with the next example that we bring up. So let me close this. Do I want to save that? Sure, I guess. And I'm going to bring up the next one, which is Calculator Console 1. All right, you've got all these except for the first one, that Calculator Console 00, but I did email you a text file with a source for that one in during the break. All right, so now let's bring up this one. All right, now notice what we've done. Now we've got a thing called input number, and we're passing it a 1 if it's the first number we're inputting, and we're passing it a 2 if it's the second number that we're inputting. Plus we got the word false in there. Well, what the heck is that for? You're going to see it in just a moment. All right. Now, our last program was 137 lines. Now we're up to 184. But what's good about it now is watch. Enter a first number. Hello. Oh, what the heck? Where is the rest of that code? All right, it's in the next example then. That's fine. All right. I must have another example that I've written. But, oh, you know what? It is in here. I did not set my startup project. There we go. All right. So let me get rid of this. And there we go. All right. So now I'm going to run it. Input number 1. I'll leave it blank. All right. The value is not a number. Please try again. Hello. Same message. All right. Now put in a number, 345. Enter the second number. The same thing will happen. Leave it blank. Put in something non-numeric. Put in 23. Now enter an operation. I'm going to try to put an operation in here. I don't know how that happened where my cursor's there. It should be here. But I'm going to put in blank there. Illegal operation. Try again. Hello. Still doesn't like it. All right. Minus. Now it does 345 and the 23, and it gives me the result. Plus, I put it, instead of using an infinite loop, I ask the user, do you want to do it again? Yes or no. So if I say Y for yes, all right, well, I guess I didn't make the right check, but that's okay. We're going to go through all of this right now. All right, and again, if you've got questions, please ask. I tried to annotate this with a lot of comments. All right, so taking it from the top, this is just that thing that's going to tell you what to input for the operation, as you can tell. All right. So these variables now, I made all of them global to the program, so I didn't have to pass them around. We didn't have to do that, but that's the way that I set this up. All right. Now, I do still have in here, am I running the right one? Let me check. All right. I keep bringing up the wrong doggone program. So there it is. All right. So I've got this variable called again that I set to true. So now rather than saying while 1 equal 1, which puts it in an infinite loop, which means it's going to run forever. All right. Now I'm saying while again, and you already know this, you've seen me put this in there multiple times, but this is the same thing as saying while again equal true. It'll be true initially because we set it right there. But at the bottom, we're going to set again equal to run again or not. We'll go over that in just a moment. So the program will start. Yes, it's true. So yes, that's true. So it'll clear. Then it'll call input number. It'll pass in there the number 1 and false. What is that doing? Well, what this should have said, rather than input first number, now it should just say input number. All right, then I've got position. Well, what the heck is position? Position is either first or second, the first number or the second number. All right, and flag is going to be set either to true or false. Why would I set flag equal to true or false? Not only that, if it's going to be true or false, why is it false here and why is it false there? You're going to see all that in just a moment. All right. So here's the string I'm going to read in for my number. Here's where I'm going to attempt to parse that number, not convert, but do a parse and parse it into an integer. Here will be the result of that parse. So this will be the number read in from the console. This will be the attempted parse of num_str. And this will be the result of the attempted parse of num str. All right. Now notice what we have here. If flag. If, what the heck does that mean? If flag. All right. Well, remember flag right here is this. Now notice when we first call it, we're passing false. What is false? False is flag. The first time we go through there, we do not want to run the previously inputted value is not a number, please try again. We don't want to do that because we haven't read in a number yet. That's why we're passing it in as false. But if we read in a bad number, we're just going to call our routine all over again. Now we're going to pass in true. So when it gets here, flag will be true, so it will print this out. So in other words, what you see in blue right there will be skipped when we first call the routine, but if we call the routine again because we put in bad input, then that flag will be true. All right. Now it says input number and position. So it'll either say input number 1 or it'll say input number 2. That's what position is. All right. Let me get rid of that. All right. So it'll be number 1 or number 2. So the good news is now, even though it's bigger, I'm going to make it nice and small. All right, very small, I guess. So you can see, and I'll make it bigger in a second. But now that's a good, almost, really it's 30 lines. But what are we doing in there now? Well, we're writing one routine to handle 2 different numbers. So it's like, all right, so we've cut it down somewhat. And we're validating. Previously, rather than doing a convert dot to int, now we're doing an int dot try parse. What's the difference? Convert dot to int assumes it's going to work. Int dot try parse does not assume one thing one way or the other. So again, if this didn't work, remember that means this right here is the same thing as saying if result equal false. So if this doesn't work, we're calling the same routine we're already in all over again. And we're passing position, which we've already passed in. It's either the first or the second, but now we're passing in true. So when we call it again, that'll be true and it'll write our error message. Then if we get down to here, we did pass in a valid number. So if it's the first one, we set num1 to that. And if it's the second one, we set num2 to that. And that's it. So I'm asking this question before I go on. Logically, do you understand that this particular routine is both inputting a number and validating it to make sure it makes sense? If you have any questions, ask now or forever hold your peace. All right. So we do that for the first number and we do it for the second number. So when we get down to here then, we should have 2 valid numbers in there. So we go to input operation. And guess what? It's the same thing we had before. There's no change. If this looks a little long or bewildering to you, let's break it down. What are we saying there? While the operation is not a plus and it's not a minus and it's not a multiply and it's not a divide and it's not a modulo, what does that mean? It means we put in some character that wasn't one of those. We put in some input that did not match one of those. All right. And if that confuses you, take a look at it because it is a complex condition that we're doing ands with. Remember, with an and, every one of these must be true. So it can't be this, and it can't be that, and it can't be that, and it can't be that, and it can't be that. So if we put in anything that wasn't one of these, we're going to get the illegal operation, please try again, and then it's going to wait for you to try it again. All right. And that's going to be put it in the operation. So we're going to be hung up in here until we get something valid, a valid operation, one of these 5 things. Then we come back to here and we call perform operation. And guess what? That's the same thing that we had in the previous program. All right. So if we put in a plus, we're going to call calculate and display sum. If we put in a minus, we're going to call calculate and display difference. If we put in a multiply, calculate and display product. If we put in a divide symbol, calculate and display quotient or modulus, we're passing in the 1, meaning that was a divide. If we did a modulo, we're calling calculate and display quotient or modulus, but we're passing in a 2, meaning it was modulus. All right. Then we get down to the bottom. And we've got this again equals run again or not. Let's look at that. There it is, not long. So answer is what's going to get displayed on the screen. It's going to say run program again, answer Y or N, please. Now we're assuming that when we tell the user to enter a Y or an N, we're assuming they're smart enough that they can do that. All right, they may be or they may not be. So what we're doing is, this is answer is whatever they entered. We're plucking out the first character. Answer sub-0, that'll be in chapter 8, so this is coming. But the first character is, we're sticking it into first char. And I should have made this to say this. This should be changed on yours. Not equal this. And let's see. If it's not this, or first char is not equal to lowercase. All right. I've used 2-upper, but 2-upper is meant to be used with a string. This is a char. This is a single character, a char. So I'm just checking the first character that somebody has inputted. Just the first character. This is grabbing everything. So if they put in there, yes, indeedy, or yes, I do want to run it again, first char will just print out the Y from yes, indeed. Then I'm going to check, and if that first character is not this, let's see, if the first character is not equal to Y, and it's not equal to small y, so it's not one of those, all right, we're done. So let's see if that works. Hopefully my check is correct. So I'm going to do a save all, and I'm going to run this again. All right, so enter number 1, 56. Enter number 2, 17. Enter an operation. Multiply. This should give me 952, I believe. Yep, there it is. All right, do I want to run the program again? I'm going to say Y for yes, and it lets me do it again. So I can put in 45 and 12 and divide. Okay, now it asks me, do you want to run it again? And I'll put in no, and I'm out. All right, now that was a lot to throw at you. So I decided to give you this program, this series of programs, all right, because I want the stuff to make sense to you. I'm still getting emails from people that are saying, I took the test and I had problems with this number, and it's like, this doesn't make any sense. Well, again, I'm going to continue at least for a while. Before you get your tests, you will have homework and you will have pretests. And the pretest should help you take the test. All right, this is the kind of program I could potentially put on a pretest. Now, are there any questions on this particular programming example? This one. All right. Then I'm going to go on and I'm going to start going over calculator 2. I believe we took our last break. All right, I gave it to you at 9:05. So it ended at 9:15. So at 10:10, I will give you your next break. So now I'm going to bring up the first GUI one. Let me close this. All right. So here's the first GUI, and I'm going to immediately set this to set a startup project and bring that up. All right, so we're going to look at all of this that's in here in just a moment. All right, it's going to look pretty ugly for a while, but let's look at it. I still brought up calculator 1, so let me close that. And that's it there. All right, there we go. Now, there's something new in here. The new thing is this. All right, this is referred to right here as a combo box. You'll notice if I come up over here, there's a thing here that says combo box. And it says displays an editable, when I put my mouse over it, it says displays an editable text box with a drop-down list of permitted values. When I run this program, notice what's in here. Whoops, thought I said it, but I said it for the wrong one. So set it, start a project, run it, there it is. So notice what's in here. That should look familiar to you. Plus, minus, multiply, divide, and modulo. And I'm going to quickly run this, and I'm not going to put anything in here, and notice what I get. No value input, no value inputted for number 1. If I put in something like this, non-numeric input for number 1. All right? And if I do put in a number, it'll go through the same thing, but now it'll say no input for number 2, non-numeric input for number 2, and there's actually one more possible condition. This will work, but this is editable. So I can go through here and I can remove that. So now there's nothing in there. When I click calculate, nothing chosen for combo box. It says it's empty, so I'm going to automatically just reset it to a plus sign. And when it does that, this should be a plus, and this should say 45 plus 12 equal 57. And you can see it does. Now, I'm going to go over this in a lot of detail, but my question for you is this. Conceptually, do you understand what's going on here? So if I come through and put in 34 divided by 7 and click calculate, I get that answer. If I change it to plus, I get that answer. Minus, I get that answer. Multiply, I get that answer. Divide, I already showed you. And there's modulus. Now I made the answer always. I just set the answer up to be 3 decimal places. But my question for you is, and again, if I hear silence, fine, I'm going on. Is there anything conceptually about what's happening here that doesn't make sense to you? All right, then let's look at the code. Now, I'm to the point where if I click on here and I go to view tab order, you can see that my tab order was set. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, view tab order. And if I click on here and I go down to my properties window, you can see here I've changed the name of the form. I have set I didn't set the accept button, so I'll set that now to BTN calculate. All right, I didn't set my cancel button, shame on me. So I'll set that to BTN clear. And if I go down to start position, I've set it to center screen. And for my form text, I put in here AWD1100 Chapter 6, a simple C# GUI calculator. So I'm assuming, right or wrong, I don't have to talk to you about that stuff anymore. That you're going to assume that you should put that in all your programs. All right. Those of you who didn't on the test, you should have gotten an email from me yesterday that had your test page on it, just the last page, and if I did take off, why I took off. You're always welcome to fight me for any points you can. I have no problem with that. All right. Or if you ask me to regrade it, but when I regrade it, I regrade the whole test. Also today, the only thing that I've graded from your homework and labs and written tests have been the written tests. That has already been put into, and I talked to Mr. Gudmiston, and he said, no, I'm grading them. And if there's 41 questions, they're getting a score out of 41. So that's what I'm doing. But it's only worth 10 points. So let's assume that there's 40 questions in there and you only get a quarter of them right. So you get, out of 40, you get 10 right. So you will get, instead of 10 points, you will get a quarter of 10 points, which will be 2.5. All right, because again, I'm supposed to try to keep lockstep with him as much as possible. All right, so when I clear, what do I want to do? I want to clear, I want to clear, I want to clear, and I either set that to something manual or not. All right, just so you see this too, if I come down and click on my operation, there's a thing in here called items. All right, and it says collection on it. And if I click on it, choose the ellipsis, that's where I put in all those values. All right, so we could have put in here as an example. I could have put in here operation. The reason I didn't is what'll happen when I run this. All right, I manually put that in there, but notice what shows. I didn't want that. We could have done that. Those of you who were in the AWD 1000 class last semester, you know that when we had drop downs, for example, for a state, when we put in all 50 states, normally at the top, we would put in something like, please enter a state. All right, I'm not doing that here, although again, we could have. Just get rid of that and say okay. So when you do that, you can click in collections and manually put in the stuff here, or we could have also put it in our in code. We could have done it that way too. You're going to see this. We're going to have a whole chapter that's going to go over these other controls. So if you don't get the control, don't worry about it. That's what I'm saying. All right. So let's see. And when we click exit, it's just our exit button code. It's the same stuff I gave you that we've been working on for a while. Nothing new in there. I did put in a show message, show error message. Didn't have to, but that's allows me to create my own custom error message. You've seen that before. And again, the exit, nothing new there. Really, there's nothing new in here, except in the combo box, I just set it so that the default is the plus sign. If I didn't do that, I could have just said equal double quote, then there would have been nothing in there. So I made sure there was something when we started. So that's the first text box I'm clearing. The second text box I'm clearing. This is the result. All right. This is setting that combo back to the plus sign. This is an error that I didn't see. That should have said dot focus. All right. So I didn't notice that. It's my own ignorance, but that's fine. So that was that. So my guess is, my hope is that there is nothing for this and for this that don't make sense to you. All right. So let's go on and look at calculate. And there's as always, there's a method to my madness, and that method is this. When we go down far enough in here, all right, perform the add, perform the subtract, perform the multiply, perform the divide, perform the modulus. And when you look at these, look, they're basically the same thing that we did in the console, except instead of using a right line, we're setting the text for our label. And so what I want you to get is the logic is the same, whether we are doing something in a console application or in a GUI app. Logic is logic. And in fact, if I was doing this program in another programming language, It would still be the same logic. The only difference would be syntactically, the way that we set stuff up. That's all. All right. So here were our error messages. So if there was nothing that was put in there for input, it says no value input. This is what's going to show in our show error message. If we put in something non-numeric, that's what's going to show. If we leave that combo box empty, that's what's going to show. All right. And here are my error messages. So this one will say no value inputted for, and I will manually pass in something like text box 1. Same thing with this. I will manually pass that in. This you already saw, empty resetting the plus sign, and this we'll hit on in a minute. We don't want to let the user attempt to do an illegal divide by 0. All right, so again, declare and initialize our global constants. Here are our variables. I made them doubles. They could have been decimals. All right, and I made them doubles because, hey, when you do a regular calculator, there's nothing that stops you at all from saying 56.34 plus 34.18, 19, and getting that answer. That's totally legit. That's why I made them doubles. Plus now when I do the divide, it works. All right. And when I do the modulo, it actually works. It is 22, and what's left is 15 hundredths. All right. I'm not saying it is 15, but it's 15 hundredths. All right. And you typically don't do modulo with doubles, but I just decided to leave it that way. I just figured I didn't want to get too hung up on that. So clear works. All right, etc. Okay. So again, these are my two input values along with that combo box, I guess. And this is the calculate. This should look pretty familiar to you by now. A lot of you use this when you did your test. In fact, most of you did. And I want to say, all right, I'm not going to bring the test page back up again, but with at least 3 of you, you lost 5 points because it had said on the number where it said you had to use a switch statement for the one on grades. And if you used ifs, you lost 5 points there. Now, maybe you think, well, that's pretty severe, but that was one of the main things on that problem was that you did a switch statement. All right. So it was on there. All right. So this is our keep going thing. Again, you could call that again or whatever. So I'm saying validate number 1. So now what am I doing in validate number 1? Well, there it is. I'm saying if there is nothing in it after I trim it, give that first error message, which will say basically no input for number 1, and then we'll have our title and we'll set red val equal to false. Otherwise, there's something in there, so we're attempting to parse it. If the parsing failed, we're giving the second message, which will say non-numeric input for number 1. Then we come down to here, and we just return ret val. Well, then notice what we have in here. Okay, we've got this number 2, and we're doing the same flaming thing. Wait a minute, you just told us, Jeff, that we weren't supposed to do that. Yeah, but it's going to be done a little bit differently in here. And I actually showed you this earlier, but it's in Chapter 7, so you're going to see it tomorrow. I'm going to make a change to this program. That is, coming back here, every single control you put on a form has got a special property called tag. And I'm going to call this one number 1. And I'm going to put a tag on this one. And I'm going to call it, here will be a surprise, number 2. By just putting that in, putting a tag there that says number 1, that's right over here, and putting another tag there that says number 2, that's right there, it's going to give me the opportunity to take these 2 routines, which collectively, including the comment, start where? On line 57, and go all the way down to 117. So about 60 lines of code and cut it in half. We're always shooting for that. Now, that said, think about this. Let's pretend you're Joe Programmer. And if somebody says, yeah, we got this program we want you to write here. And if you write it in one way, where you've got 1,000 lines, but then you know some shortcuts, you've been programming for a while, and you've got some shortcuts and you can rewrite it as 250 lines. So in other words, you've cut 3/4 of the code out. Which would you rather have to go and maintain? I'll take the 250. Years ago, I went to a class in downtown Milwaukee, and it was on a weekend. And I remember the class for 2 reasons. The first reason is the guy got in there and he had a whiteboard. And it was the longest whiteboard I'd ever seen. It was about the size of about 3 regular blackboards, okay? So they gave him, of course, some whiteboard markers. So he said, well, look what I've got to draw. And he kept going. He went through one and he kept going and he kept going and he kept going. He didn't realize he was off the whiteboard and he started drawing right on the wall with whiteboard, which I found funny. All right, that's first thing. Second thing, this was a class on databases. And what this guy did for a living was he was contracted out to different companies. And they would say, can you fix this in our database? Can you add this? Can you fix this? Etc. And he would think about how long it would take him to do it. And then he would always come back and say, yeah, but it'll take you 2 to 3 weeks. And they were like, wow, you can do it that fast? Yeah, 2 to 3. 3 on the, on the long end. So they would agree. Guess how long it took him? The answer is typically 1 day. But he had this mammoth script that he wrote that would handle almost anything he had to do. So what he would do is in 1 day is he would take that script and apply it to the problem he was working on. And he'd usually get it done and tested in 1 day. That said, he wouldn't let them know he finished it in 1 day, but he'd spend the rest of the time refining that script. Then after 2 weeks, he would go tell them, hey, I've got good news for you. I finished it, and it only took me 2 weeks. They were happy because they thought it would take 3 or 2 to 3, and it only took 2. He was happy because 9 business days out of the 10 that it took him to do this, he was just working on his own stuff, basically. All right? So the moral of the story is, no, not to sit and screw with people who hire you, but try to sit there and write stuff in an intuitive way, but also in a way that makes that has the least amount of code, so when you have to maintain it, you're able to do so. All right, end of that sermon. So I've now gone through with you the validate number 1. I mentioned to you that the validate number 2 is the same, except every occasion where you've got a 1 in there, you put in a 2. All right. Then we validate our combo box. Now, when you look at this combo box, when I run this right here, there are, I think you would agree in there, 5 different things. Combo boxes have 2 features. One is a value. So the value you see right now in blue is a plus sign. The value below that is a minus sign. The one below that is a multiply sign. The one below that is a divide sign. And the one below that is a modulus sign. Okay. They also have what's called an index, which tells where they are. The one in blue is 0. Then it goes 0, 1, 2, 3, 4. If nothing is chosen, remember, I can remove this. So if there's nothing in there, then what's called the selected index is -1. So that's what I'm checking for here. If nothing was selected, I want to show error message 3, which is combo box empty resetting to 0. That's what I want to show. And I want to set my return value to false. It didn't work. Otherwise, there is something in there. All right, where's my combo box? There it is. All right, but I got an error, so I just default it and set it to a plus sign. So what I'm showing you in there, and I'm sorry, I decided to put this in because I thought it would be easier than having you manually enter a plus or a minus, because this is a control we're going to end up using quite a bit as we go on. All right, I believe that on your next test, there won't be anything like this. I'll double check, all right, but I don't think there is. It also makes your program, as we come down here, I think at least, easier to read. Now, notice I did a thing here on the selected index, and I did 0 and 1 and 2 and 3 and 4 and a default. But I could have done it instead of on the selected index. I believe there's also a selected value. Maybe I'm wrong here. Give me an error. No. And then I could have put the plus sign in here in double quotes and the minus sign in there in double quotes, etc. All right. Maybe that would have been a better way to do it. All right. But I didn't do it that way. All right. But I did put a comment over here that said, hey, that's a plus sign, that's a minus sign, etc. If I ever decided to change the order that you see in these boxes, I'd have to go back and make a change then. Or if I decided, you know what, who cares about modulo? And if I got rid of it, I'd have to go back and actually manually change this then. All right. So now I come through here, and again, if it's a 0, perform the add. If it's a 1, perform the subtract. A 2, perform the multiply. A 3, perform the divide. A 4, perform the modulus. I'm not doing anything. This should never be hit. I could have just said call the add, but if I get in there, something else is hosed in my program. Always get used to the idea of when you run a switch, put a default in there, even if it just says break, which means get the heck out. All right. So here's the add. Again, virtually the same as the way we did the add for the console application. Then we've got the difference. Again, virtually the same as the console app. Then we've got the multiply. You heard me say it, virtually the same. All right, and then we come up here to perform the divide. And I decided to take this and break it up into its own routine. So notice it says keep going this is just the divide. So I didn't do the divide and modulo together, although I could have. But with both the divide, it calls check for 0 denominator, and modulus calls check for 0 denominator. Another reason for writing yourself a routine. I'm calling it from more than one place. So if I'm trying to do a divide and the second number is 0, or I'm trying to do a modulus and the second number is 0, I instead come in and I set my text to illegal attempt to divide by 0. And if I run this and I put in here 52 and I'll try to divide and 0, what do I get? Illegal attempt to divide by 0. Let's change this. I'll just make it 10. All right, so now it's good. But I'm going to come back and make this modulo. And I'm going to make this 0. And you see that it works for both cases. So I ran through that quickly. I understand that. I ran through that quickly. All right. I've got one more version of this. I don't remember offhand what's even in these. I wrote these a couple days ago. All right, but I've got one more GUI on this that we're going to take a look at after the break. It is 10:15. Please start your 10-minute break as soon as I come through here, and I'm going to change my screen. Hopefully it went back to my email screen. And this is your 10-minute timer, which starts now. It's going. Again, I'm going to refresh my water, and I'll be back in about 5 minutes.
Mr. Scott.
Yes.
When is the homework gonna be due? And like when?
We're gonna talk about all that in just a minute.
Okay.
All right, again, I'm back. The question was just asked about homework. So let's see if I have that with me. Probably don't. No, I don't. Okay, great. I'll have to find that. So hold on just a sec. There, I think that's it. All right. So far, we've gone through this. That was 2 weeks ago. We run through this, okay? Now, evidently, and I was going to do this at the end of class, but since the question was asked now, I'll just go through it now. If I go through a program in class, you do not have to do that program. You do not have to turn in that program. But any homework or any lab that I do not do with you, you are responsible for doing and turning in. All right? I'm going to say that one more time. If you remember, I think we went through Lab 4.2 and Lab 5.3 and Homework 4.2 and Homework 5.3 or something like that for chapters 4 and 5. Since we've already done those, I did not expect you to do them. But the other labs that we didn't go over as a class, the other homeworks that we didn't go over as a class, I expect you to do those. Does that make sense to everyone? Any questions on that? All right. Now, some of you weren't complete with what you turned in for homework or labs. All right. So what I'm going to do is I am going to, and this is like a one-time shot, if you didn't do all the homework and you didn't do all the labs, you can have until this Sunday to turn them in. All right. After that, they're just going to be late. I really don't have time to, when people start turning in stuff real late and whatever. I will tell you, if I haven't mentioned this to you already, I have had upwards in this class, in 3 weeks, I have had upwards of 500 emails from people already. That's how many questions, et cetera, that I've been fielding on this. So you can have until then. Also, because we've fallen a little bit behind, I'm going to change the date on this one so that it's due 1 week from today. So that'll be Sunday, February 2nd. Now, the problem with doing that is I'm supposed to grade you based on whether or not you turned in something that week. And I know that's a little difficult. So I'm going to end up marking everybody present probably for this week. All right. Now, going back to this. Last week, this is, or this week rather, this is what we've done. Monday, we had the hands-on test. Tuesday, well, yesterday it was supposed to be that, but we pushed all these down. All right. In other words, this day right here that's tomorrow, became this. And this day that's right here became this. And this was over each test problem. So you can see, and it's important to me that you understand concepts before we go on. The only problem is I don't want it to where we're at the end of the semester. Now we're out of time and there's been a bunch of chapters we haven't covered. But especially with where we are now, I don't have a problem with this. So this is what we are today. We've gone over, I've lectured on chapter 6. I'm going over problems right now. Tomorrow, I'm going to lecture on chapter 7 and go over problems, okay, the same way. All right. Then what I'll do on Friday, now it says lab all period, I'll be on Teams. We're going to change that. All right. And I'm going to put it in lab all period, but I'm going to put that there. What do I mean by that asterisk? We're going to end up doing most, if not all, of the homework, the exercises. We're probably going to do all of 6.1, 6.2, 7.1, and 7.2 together. So you will not have to turn those in, but you will have to turn in the labs for 6 and 7, which we'll go over later on today. Then what I'll do is I'm going to push this down as well. So the actual test is going to end up being Wednesday, which is 2-2. All right, so that'll be the hands-on test. So next week will look like this. Today again, we're starting it with today, the next week, I guess. Chapter 6 today, chapter 7 tomorrow. Friday, we will end up going over those problems that are our homework. We'll do that together. All right. So again, anything that's like that, when I'm actually going over actual homework, is only on the Teams URL. When I lecture, they'll be both on the Teams URL and out on YouTube. Monday of next week will be lab the entire period. Period. That's it. Lab. And as it says there, I will be on Teams. So I will open up a session. If it's 3 hours and 50 minutes of dead air, not a problem. Then it's 3 hours and 50 minutes of dead air. Tuesday, by the time you get and start here Tuesday of next week, so 6 days from now, at 8 o'clock, I will email you out a pretest that I will create this weekend. You will have from 8:05 a.m. till 10 a.m. to complete the pretest. From 10 a.m. until 11:55 p.m., I will take the pretest. Then 1 week from today, you will have the hands-on test for chapters 6 and 7. Now, with what I just went over with you right now, are there any questions?
Yeah, so when are the labs due? Exactly.
They're all, so in other words, this Sunday, we said we'd push this off to Wednesday.
Okay.
So the labs and the homework and the written tests will be due a week from today. If you did not completely turn in the homeworks for chapters 4 and 5, or you didn't turn in completely the labs for 4 and 5, or you didn't do the written tests, or any combination, you've got until this Sunday to turn that in. If you do that, so if you're turning in something late, then please just email me to let me know, because some of the stuff I've graded already. I have graded your written tests, but there were quite a few people who didn't have homework or labs, or they were very incomplete. Did I answer your question?
Yes.
Okay, so that's that. And I'll leave that up there for just a moment. So people who are watching this tape on tape You can do that. I hate to email that out just because of the fact if it changes, then I got to email it out again. All right, so this change is not that last Sunday. This is this Sunday. All right, if you've already turned it in for 4 and 5, then don't worry about it. You're cool for that. You've got a week to get the 6 and 7 stuff done. So I'm going to keep this thing. I'm going to add to it every week. And then where I've got this week and next week, I'm going to change that. So when I get to Friday, then I'm going to remove this. And where it says next week, it'll say this week, and then I'll have the following week. Hopefully what I'm saying to everybody makes sense. All right. All right. So let's go back. Unless there's any other questions, I'm going to jump back into Visual Studio here. And I'm going to bring up Calculator GUI 3. So let me set the startup project to that. And let me bring that up. All right. And again, it's probably very close. So let me look at the code here. I'm trying to figure out what I did differently on this one. And I don't know what I did differently. Just taking a quick look at it, it looks like it's the same program. So I'm not even going to go over that. So I'm going to forge ahead here. All right. Let me tell you quickly. When I say quickly, I mean like in a matter of seconds, that tomorrow in class, we will be going over Chapter 7. All right. Why am I telling you that right now? And that's what we're doing tomorrow. Well, because tomorrow, when we go over to Chapter 7, in many ways, it's an extension of Chapter 6. So notice, validate data. That's what we've been doing today. I've already been showing you that. Handle exceptions. We'll talk all about exceptions tomorrow. Not right now. Not a real long chapter. It's 24 pages. But we'll talk half of it, exception handling, and the rest will be validating data. And it'll talk about that tag attribute that I showed you, etc. All right. Well, why? So fine, Jeff. That's all fine and dandy. Why the heck are you telling us this now? I'm going to show you. Because the next programs I'm going to bring up on here, I'm going to close all of this. Sure. And I'm going to bring up the last two that are in here. They are MPG, which is miles per gallon, console, and MPG GUI. So let me first bring up the console. So those of you who had the class with me last fall, the JavaScript class, these things in here should look pretty familiar to you. I'm assuming that the minimum miles you can drive are none. Really, I probably should have made it 1, but you get the idea. The most miles you can drive are 1,000. The default that I'm going to make is going to be 100. The minimum gallons you can use is 1. The maximum gallons you can use is 100. And the default will be 10. Now, if you don't like my numbers, of course, you could always go in and change them. You're not turning in anything with this anyway. So we run the program. So right now, notice it's already been modularized. So I clear the screen and then I set miles. I set it equal to the return value of a method called input and verify miles driven. What does that mean? That means that input and verify miles driven must return something of type decimal. And you can see that it does. Miles driven. Then I set gallons, and that's gallons used, equal to input and verify gallons used. All right. And what is that one doing? It's got to return a decimal, and there's gallons used. So by the time I get to right here, I can be 100,000% certain that I have a valid value for miles and for gallons. Does that make sense to everyone? If I hear silence, cool. All right. Then I call display all, and notice I'm not setting that equal to anything. That means there is no return that means the return type on this is void. It's void of a return type, or in other words, it doesn't have one. So I want to go over this because I'm going to actually change a couple things as we get into this. It's totally fine the way it is, but I want to demonstrate a few things to you in here. So if I run this, just so you can see it, so let me run it. Whoops. As always, I forget to change my startup project. So there's that. Now it should work. All right. So if I come in here and I put in something out of range, -34. Says illegal input, it's automatically resetting it for us to a default value of 100. All right, so now it's 100 miles we drove. And I'll put in -34 for the gallons used. Again, it's reset it to 10, and then it says miles driven 100, which is the reset, gallons used 10, which is the reset, and 100 divided by 10 is 10. All right, if I run it again and I do put in something valid, so let's say that I drove, I don't know, 456 miles, and I used 22.8 gallons of gas. That says that I got basically 20 miles to the gallon. Well, that's showing me a few things. Like what? Well, when I did this, notice 20 and 22 times 20 is 440. I did not keep the decimal place in here, which I should have. So I'll fix that. All right. But I can keep running this now. And when I'm done, because I just set it up in an infinite loop, I just click there. So again, I'm asking the question, is there anything that I just showed you right there that does not make sense to anyone? All right, so I'm going to put this as minimum miles, I think that's right, miles driven. Find that out, there we go. And then this one will become, in fact, I'm just going to set it to 1. You've got to at least drive a mile. All right, we could leave it at 0, it wouldn't hurt anything. This will be maximum miles driven. This will be the default miles driven. So in other words, if something illegal is put in, we're just going to set it to a default amount. This will be the minimum gallons used. This will be the maximum gallons used. Maximum gallons used. And this will be the default gallons used. So again, I'm asking the question I will continue to ask. So if you're already bored of it, those of you, this is your first class, you'll get to hear it over 3 semesters. Any questions on anything here? The maximum, the minimum, and the defaults, they're arbitrary values I just picked up. I just came up with those. So they could be changed to anything we wanted. If we knew that no car, if we knew that no vehicle could go more than X number of miles, we could change that. All right, so there's that. So in here, infinite loop on purpose. In here, we're going to clear the screen. All right, then we're going to come in here. I'm going to put the comments up here. As it says, input and verify miles driven. If miles driven input value is bad, I'm just going to say bad, like either we left it blank or we put a non-numeric in there. Set miles driven to default miles driven. Right? That should make sense, or hopefully it does, to everyone. I'm going to copy that whole comment. And I'm just going to change that to gallons used. Whoops. Then here, I'm going to say calculate miles per gallon using formula MPG equal miles driven divided by gallons used. Right? Then finally, I'm going to display all input and calculated values. All right, now that's going a little nutso with the comments, but you know what? Again, I'm sorry, I know that at least 2 or 3 of you have heard this story already, but I'm going to say it quick. I worked for an aerospace company in Rockford, Illinois for 11 months. When I first got there, they gave me a bunch of assignments, all right? Eventually, I got this big, long assignment. I wrote a program that including comments, the program was 11,000 lines long, all right? Out of those 11,000 lines, approximately 4,000 of them were comments. I did that because I knew I was leaving and I wanted to make sure the person who took over there for me was able to understand it. So I did complete program runs, copied them in screenshots, and pasted them in as comments. I asked the guy, his name is Mark Wilson, who was taking over for me. I said, Mark, does it make sense? And he just literally laughed. And he said, you put frickin' program runs in there. How could I have questions? Everything I could think of is in there as a comment. That's why I did it. All right. So we're going to look at this, then we're going to look at this, then we're going to look at this, and finally we're going to look at this. All right. So what are we doing in here? Implement and verify miles driven. All right. The way that this is being done should look really familiar to you. So we're coming in here and we've got our Boolean result. And remember, that automatically is going to set that to false. And we've got our miles driven, which should set that to 0. Then we are telling the user, input miles driven between, and notice I use my constants. So this will say input miles driven between 1 and 1,000. So this will be input miles driven. And this will be attempt to parse value inputted for miles driven. All right. So we input it and we attempt to parse it. You know that when we run try parse on any type of variable, try parse returns a Boolean, meaning it returns true or it returns false. All right. And there's a lot of try functions. There's more than just try parse. All right. So just to show you, if I came in here, I think it'll grab this. If I typed in min miles dot try, oh, let's see. I guess it didn't want that. It wants a variable. Of course it does. Well, it's not showing it there either. You'll have to take my word for it. There's a try parse that you can use. Oh, that's the problem. I got to give it a variable type. There's a decimal dot try parse. There is a double dot try parse. There is an int32 dot try parse. There is a string dot try parse, etc. So all of the major types of variables, there is a try parse for it. All right. So this will say if either A, the try parse failed, or the value inputted was negative. All right. In fact, I really should put that in there instead of that. I shouldn't have used that. I should have used min miles. That would have been cleaner. All right. Well, and we'll change this to 0 or less. All right, so if either one of those are the case, we are just writing a line that says illegal input, setting miles driven to a default. Now, just so you know, instead of doing this, and we'll talk about this more tomorrow, I could have made that a while statement. And if I made that a while statement, I'm gonna copy all this and show you what I mean. Right? I'm gonna put all that in here, and I'm gonna change that to a while. Now I could have done that, and I could have literally just changed it to this. And it's important, and that's why I'm showing this to you. Now, as long as either it didn't work or we put in a value of 0 or less, we're just going to ask you to do it again, and we're going to parse it. If it fails, you're going to go right back up here and do it again. Does that make sense to everyone? And if is a one-time shot. That's why I just set it to a default. The while loop, on the other hand, is not a one-time shot. This while loop is going to keep us stuck in here until we put in a value that's positive. And also, let's see, the other thing I could have checked for in here, now that I think about it, or let me put this over 3 lines so you can read all of it. All right, now I'm checking for everything. So while either it failed, or I put in a negative number, or I put in a number that was greater than that. So that if that you saw up there really should be this if here. That one, that would have been better. That is much cleaner. All I'm trying to show you here is when you are writing code, much of the code that you write is what's referred to as defensive coding. All right, why is that important? And again, sorry if those of you who had me last semester heard this already, but I'm going to say it again anyway. In many ways, and I may have even asked this in class, I don't remember, but in many ways, defensive programming is like car insurance. You're supposed to buy car insurance, but you pray to God you'll never need it. In much the same way, when we check this, we're hoping that our input was always valid. But if it wasn't, we want to make sure it's handled. We're going to talk about that in much more depth and breadth of coverage tomorrow when we go over Chapter 7. Like I said to you already, much of the information in Chapter 6 dovetails that which is in Chapter 7. So this is our thing. And like I said, I redid it. Originally, I only had that and I had less than 0, but I added this for completeness. All right. And I am going to copy that particular comment and that if so I can use it down below. All right. So now we're going to do the same thing with gallons used. So again, I want to change this. So if either the try parse failed or the value input was, I think this one is less than 1, or the value inputted was greater than, I think that one was 100. I could be wrong on that, but this is now gallons used. So is this, which means I've got to change this to min gals. And I've got to change this to max gals. And I got to fix my spelling there. All right. So what we're doing both in this routine here, our input and verify miles driven is, yeah, we're doing both those things. We are inputting a value for miles driven, and after we input it, we are verifying that it falls within our allowable range. All right. And if it doesn't, we're just setting it to a default. So either we put in a valid value, so this succeeded. If that succeeded, we skip all this and we just return the number. But if either we left it blank, or we put in non-numeric, or we put in a negative number, or we put in a number greater than 1,000, then this will be true. We'll reset our miles driven to our default, which was 100, and we'll return that. And you're starting to get to the point where, sorry, we're having the talk. No, not the sex talk, but the talk. This has got to start making sense to you. All right. And then we're doing the same thing with gallons used. So again, we are inputting it right here. If the input succeeds, we're just going to return it. If the input fails when we verify it, all right, so if this fails, and it fails again, either because we left it blank, or we put a non-numeric value in there, or we put in a value less than 1, or we put in a value that was greater than 1,000 or 100. If we did one of those, then this will be true, so we will write that in there. We will give it a default value and we'll return. So the way that these will both work then is either we do this, we put in a valid value. We parse it, it's valid. So this if is not true. So say we put in 100. So we put in 100 right here. The parse succeeds. This if is not run because there's nothing to run. So we return 100. We run it again. We accidentally or purposely put in negative 100. All right. This still succeeds. But the number we put in is less than that. So we will come in here and do this, setting it to a default value, then return. We did it again and we put in an extra 0 in there, so it was 10,000. So imagine we put in 10,000 here. It would succeed right here, but it would come in here and it would fail because it would be greater than 1,000. So we do this. All right. And the same type of thing in here. Now, what that does is it takes our calculate MPG and it makes it real simple. All right. Now, for some reason, MPG, what I thought when we did this, let's run it to double check. So let me do a save all and let me run it again here. And I'll put in 347. I'm making this number up. And let's put in here 18. All right. It did do it, 19.28. So I do have my number in there. All right. That's good. All right. And then finally display all. Now, this is where I want to tell you something. I don't know if we've covered it yet or not, but we're covering it right now. When we wrote this program here, we've got variables in here. We've got a variable here that's called miles. We've got another variable here that's called gals. Miles is miles driven, gals is gallons used. MPG is MPG. When we're passing it, we pass it those names. Those names that you see right now in blue, those are referred to as actual parameters. So when you pass those parameters, those 3 values there to a routine, they have to have the exact name they were given here, here, and here. However, when we use them inside of our routine, we can give them the same names as I did, but we don't have to because in here, they're referred to as formal parameters. So I'm going to make this an M, I'm going to make this a G, and I'm going to leave MPG the way it is. Now I'm going to make that an M, and I'm going to make that a G. And it'll still work just fine and dandy. All right? And the point, the takeaway from there is, and I'll run it in a minute, when you have parameters inside of a routine, they do not, these formal parameters, as they're referred to, do not have to be the same name as the actual parameters. All right, and before you say anything, first let me do two things. I'm going to do a file save all, or try to. There it is. I'm going to run it to make sure I didn't break anything. All right, so we'll put in here 236. We'll divide that by 15. And it still worked. All right, so that works. That's good. But I want to show you why that might matter. So I'm going to come down here and I'm going to put this in as a comment. And I'll actually leave it in there. I think that this will work fine. If I've got that, yeah, it'll work. But let's imagine that I'm going to create 6 variables. Int, and I'm going to give them crummy names. I'll give them these names. Num1 equals 17. Int num2 equals 3. Int num3 equals 45. Int num4 equals 71. These I'm just pulling these values out of my head. All right. Int sum1 equals 0. Int sum2 equals 0. All right. Now what I want to do is I want to call a routine. Make this, I want to make it so you can see as much of this as possible. All right, there we go. So I'm going to say, in fact, I'm going to say here, int sum1 equals, I'm going to call a routine that's called add2, and I'm going to pass it num1, and I'm going to pass it num2. And then I'm going to call it again, and I'm going to call this add2, and I'm going to pass it num3, and I'm going to pass it num4. Now, if I did this right, this should return 17 plus 3, which is 20, and put it into sum1. This should return 45 plus 71, which is 116, and put it into sum2. Now, I'm going to put in here ... meaning there's some code in there. I don't care what it is. Now I come in here and I write static int add2. Now I could call these num1 and num2, and then I can come in here and just say return num1 plus num2. That might be confusing to somebody who looks at the program, because wait a minute, now here you're calling it with num1, num2, I get it, but here you're calling it with num2 and num3 and num4. So typically I would change these and make it like n1, n2. So I'm giving it generic names. What I'm trying to get across to you right here is many programmers, if they think, hey, I'm going to call the same routine more than once, but I'm going to pass different things into it, will never make their actual parameter and formal parameter, will never give them the exact same name. All right? So hopefully that makes some sense to you. All right. Now, are there any questions either on this or on the program itself, the console program? All right. Then I'm going to save this, and I'm going to close this, and I'm going to bring up the last one for the day, and that's the GUI version of this. First, let me right mouse click on it, set it as my startup project, and then let me bring this up. It's a pretty simple interface. And again, you've already seen this, but because I want to practice what I preach. 0, 1, 2, 3, 4, 5. So I've set the tab order. All right. Plus, if I click on the form, you can see I've already put some text in there. I've changed the name of the form. If I click on it, I have set the accept button. I have set the cancel button. And I have set the start position. Those are going to be things, you know, they might only be worth 5 points, but they're going to be worth 5 points, you know, and I'm going to take them off from now on if you miss any of them. All right. So I come in here and let's take a quick look. Our exit, of course, is our old tried and true exit. I did write that show message again. There's our clear. What is our clear doing? Exactly what you think. Clear it, clear it, clear it. Put the focus right there. All right. So let's look at the calculate. In fact, I'm going to move this over and move this up to the top. So now I did come in, and again, I put a min miles and a max miles, but now I no longer have my defaults. All right. Now there's pluses and there's minuses of using console programs, and there's pluses and there's minuses of using GUI programs. The biggest plus of using console programs is you got to totally concentrate on the logic. It's like a book with no pictures. It's just text. That's also one of the disadvantages of it. It sometimes makes it harder, but you're concentrating basically solely on the logic when you're doing it that way. All right. The advantage of setting up a GUI program is the fact that it's visual. All right. Again, one of the reasons that we chose the Muroc books for most of our books in here, and just so you know, it's for all first-year books. So those of you who are going to take the AWD1100 class in fall, you'll have two books. You'll have the Muroc HTML and CSS book and the Muroc JavaScript and jQuery book. All right. Okay. So I've got these. These are my constants, same as the last ones. All right. And here are my variables. Again, I didn't want to concentrate on passing stuff all over the place, so I made them global. All right. And here is my calculate routine. Again, what am I doing? I'm saying first call validate miles driven. All right. And where's miles driven? It's the exact same routine that we just did for the console, except now we're using TXT instead of using a read line. And we're doing show message instead of a write line. And we're not setting it equal to a default value. If it's not, there's nothing in there. Again, I didn't really need this line, but I'm setting the focus and I'm setting ret val to false. If I get down to here, there was something in the text box, in the miles driven text box. All right. Up here, this is checking if there was anything in the miles driven text box. All right. So we come in here. There was something in there, so we immediately attempt to parse value in miles driven text box. Right? All right. So if this is true, what do we know? We know parsing failed. Meaning miles driven cannot be non-numeric, etc. I could have made all these again constants. It would have been cleaner if I'd done that, but I didn't. All right. So we've got all that. Now we do want to clear it out, set the focus, and set ret val to false. If we get down to here, a numeric value was inputted into miles driven text box. All right. So now we've got to verify that it's within range. So make range check. Is exactly what we're doing right there. So if it's less than our minimum or greater than our maximum, we're again going to do a show message. We're again going to clear it out. We're again going to set the focus. So play computer here. All right, this is miles driven. We're asking right here, we're asking you to input it. Where is it? No, we've already inputted it. So when we call this, if it's empty, it's going to give that message and get the heck out. If the parse fails, meaning it's non-numeric, it's going to give you that message and it's going to get the heck out. If it's out of range, meaning it's less than 1 or whatever we put there, or greater than 1,000, we're going to get that message and we're going to get out. If we get down to here and none of those, none of those succeeded, in other words, so if nope, not that, nope, not that, and nope, not that, then ret val, which we set to true to begin with, is still true. So we'll return true. And I could put the same comments in here and just change everything that says miles driven to gallons used right there and there all the way down to here. All right. Finally, there's our calculate routine. And we are putting the value into our text box, 2 decimal places. Again, our clear didn't change. And again, our exit didn't change. So again, asking the proverbial question. Any questions on this particular program? Now, what I am going to do this afternoon, my class has got a lab. So this afternoon, I've got to do some grading in there for their stuff. But when I get done, I'm going to clean this up, add comments, etc. And then I'm going to resend it out. There's a reason for that. We're going to change this around a little bit. Tomorrow, when we go over Chapter 7 and I show you exception handling, you're not going to have that final code. We're going to write that together because I think there's a lot of benefit to doing that. But while you're learning this, I gave it all to you. So again, I'm going to clean this up. And then when I get done, I'm going to take the entire folder that I have that's called calculator, and I'm going to copy it into like calculator 2 or something like that. And that's what I'm going to send you. Now, last thing to tell you here, believe it or not, we're going to be done by about 20 after 11. All right. If I go to the AWD stuff, I'm going to open up a few files here. I'm taking for granted that by now everybody gets what you're supposed to do here on the written tests. I'm not going to talk about those, but I'm going to open up both the homework and I'm going to start with, not there, I'm sorry. The homework here for Chapter 4, you were supposed to do the calculate area and perimeter yourselves. We did the accumulate test score data as a class. You do not have to do anything with that one. I would like you to try to do the calculate the factorial of a number. That's not easy. You might want to Google what is a factorial to get some help. And we did this one as a class. So you are responsible for turning in for the homework 4-1, 5-1, and 5-2. Does that make sense to everyone? All right. Tomorrow, we've already got our calculator, so I'm not going to redo it. All right. And I've already given you the thing for the income tax calculator. So I'm going to go through this tomorrow or Friday, whatever, and this. So you will have no homework for chapters 6 and 7. You will have labs for chapters 6 and 7. Once again, for chapters 4, 5, 6, and 7, does anyone have any questions on what's going to be assigned, what's going to be due or not due? Anyone? All right. Then I'm going to jump into where it says, not there, the labs. All right. And I'm going to open up the labs for 4, 5, 6, and 7. I'm going to open up all 5 of those documents. Now, I'm going to tell you something right now, and maybe I shouldn't even be saying this, but I'm saying it anyway. We had a student drop yesterday. That student worked every single day of the week, as far as what they told me, from 6 a.m. till 2:30 p.m. Then they got home, ate, did whatever, and then tried to work on this work. And they had emailed me twice saying, are all these lectures going to be 3 or 3+ hours long? Many of them, yes, they're going to be. Unlike a typical college class where you get 3 to 4 credits, you get 14 credits for this class. All right, as long as you get a C or above. You get 14, I think, for all of the classes that are in the program, to my knowledge. All right, so you're going to be putting in more work. So yeah, I'm giving you a lot. You're getting a hell of a lot of lecture and examples to try to make it easier when you're working on your own. So that said, let's take a quick look at this. So this is for these labs. This is 5.2 new. I don't know if that's the first one or the second one. It doesn't matter. So this is a console that asks you for test scores, does the sum, the average, and the highest. You're supposed to do that one. All right, then they want you to redo it as a GUI program. You're supposed to do that one. Then this thing to track sales. You're supposed to do that one. Then implement that one as a GUI. You're supposed to do that one. Now, if you think that's way too much, then just implement both of them as GUIs. I won't take off. As long as you meet every requirement that's both in, that's put in there before. If you'd rather just do GUIs, fine. If you'd rather just do consoles, that's fine too. All right. Then how much was this sale? That's the other one. This one. Write a GUI app that counts the number of vowels. You are supposed to do that one. Finally, do a console that does this multiplication table. You are supposed to do this one and this one, and either this as a console or as a GUI or both. This one as a console or GUI or both. Are there any questions on this set of labs? Anything? Then I'm going to close this one and bring up the next one. So this is the other chapter 5 stuff. All right. You are supposed to do this one, which is a GUI program that does this for college admissions. You are supposed to do this one, which is a GUI program for hurricanes. You are supposed to do, you don't have to do this one because it's the rock, paper, scissors. We did that as a class. So from this one, you are supposed to do 2 GUIs, one for college admission, one for hurricanes. Any questions at all on that one? Anything? All right. Then for chapter 4. I believe this is chapter 4. Let me double check. Nope, that's 7. We'll look at that in a moment. All right. So where's chapter 4? 6, 4. There it is. So for chapter 4, this determine miles and kilometers. Boy, does this look familiar? This is your test problem, but instead of yards and meters, it's miles and kilometers. So you should be able to bang that one out. Yes, I want you to do it. All right. Well, you don't have to do the chicken and egg thing because we did that together. You do have to do this one, which is the one we looked at earlier, but GUIize it. That's it. So on chapter 4, you're doing 2 out of the 3. Are there any questions on that? All right, then hearing none, let's look quickly at the 6 and 7. So this is the homework for chapter 6. This is a fortune cookie. You click open and it'll give you a couple fortunes. I've had people in the past, like I did with rock, paper, scissors, instead of having a button that says open, they made it, took their button and they found a picture of a fortune cookie and they made it that. So if you click on that, that's fine. All right. And it says, let's see. So here are some fortunes. He gave you 8 of them. You should randomly choose 2 of those 8. So you will use random number. So if I run this and it shows me the same 2 fortunes every time, that means you did not do something with random numbers, so you will lose points. Any questions on that? All right, then what's left in here? This same GPA one that you did previously. All right, but you're going to go in and follow the extra instructions that are in here. Same thing with the counting vowels. All right, and this one, this should look pretty familiar. Not that different from the snowplow one that we did. It's not the same, but it's similar. All right, and again, this same person who dropped said, you sure seem to give out a lot of homework. That's because we want to make sure that if you leave here and you get hired as a C# programmer, you've had plenty of programs that you've written. All right. Any questions on anything here for Chapter 6? Anything? All right. Hearing none then, Chapter 7. This is a body mass index program. So if you do this and you put in a valid value for the height and the weight, you will get a BMI. All right. And what your status is, like normal BMI. If you put an invalid weight in, you'll get a message that says invalid weight. If you put an invalid height in, you'll get a message for invalid height. Now, go ahead and use what he put in there. I usually change this, but it's fine. So what you should do is you should have a constant for min weight and a constant for max weight, a constant for min height and a constant for max height. All right. Your BMI categories will be normal, underweight, overweight, and obese. And if you have to, just Google BMI and it'll show you what those ranges are. Okay? This will be an order exception. It says create an exception to check that all orders are valid. What does that mean? Well, notice the item number must be between 100 and 199. So if it's less than 100 or greater than 199, or it's non-numeric, or it's blank, that's unacceptable. For quantity, if the quantity is less than 1, greater than 12, or blank, or non-numeric, it's invalid. Otherwise, it's valid. If the number of delivery days are either less than 1, or greater than 30, or non-existent, or non-numeric, then that's invalid. Otherwise, it's valid. If everything is valid, you'll click validate and it'll say order is valid. All right. Now, I'm not going to lie to you either. Mr. Smith gives you some programs. He's got this decoder ring in here, and he's got another one later on where he uses some characters from Pokemon or something. This one is actually a good program. I like this. All right. And what it is, it says, imagine you've got 2 rings here, and each one represents the letter of the alphabet. What happens is you're writing your own code, your own word changer, your own encryptor. So the quick brown fox jumps over the lazy dog becomes this when you put that stuff in there. All right. I've had people do this one and gone nuts and found different images that they've used, etc. You can do that, but you don't have to do that. You're all of the things that you must put in here. So you must put in alphabetic characters. All right, you can't have numbers, you can't have special characters, you can't have blanks. So do that one. Are there, then there's a login exception one. All right. So you must put in a login and you must put in a password. If you do, it should come in and say welcome. All right. If you don't put in something that's valid, it'll say incorrect username or password. Even if it's, whether it's the username that's invalid or the password, you put in that one message. Forget these Build-A-Lab things. You've got plenty to do. Now, I'd suggest you don't start, even if you're up to that point, you can do the Chapter 6 homework, but the Chapter 7 homework, in order to do that and understand it, you'll have to listen to tomorrow's lecture. So the very last thing I want to say to you all today is I want to go over this one last time. If you have turned in all of the work from chapters 1 through 5, including written tests, homework, and labs, then don't listen to the next minute or so. Everybody has turned in the written tests for 4 and 5, as far as I could see. Now, if you have not turned in the homework or labs, you have until this Sunday. All right? I don't want you to redo the written tests or anything else, just those. Then next Wednesday, 1 week from today, all the work for the 2 chapters we're going over today and tomorrow, those being 6 and 7, is due 1 week from today. So this week, Monday, we took our hands-on test. Tuesday, I went over the hands-on test. Wednesday, today, we went over Chapter 6 and some problems. Thursday, tomorrow, Chapter 7 and going over some problems. Friday, I'm going to do those 4 problems that you saw here. So these 4 that you see right there, the calculator, the adding the method, etc. All right. Then whatever time is left will be lab. I will be on Teams throughout the entire class. Next Monday, 5 days or whatever it is from today, will be lab for the entire period, the entire 3 hours and 50 minutes. So you'll probably get 2 hours here, about 2 hours, and 3 hours and 50 minutes there. So that's close to 6 hours that you're going to get of dedicated class time for labs. On Tuesday, a week from yesterday, from 8 to 10, I will have already given you a pretest. I will have given you the electronic copy. You will have from 8 to 10 to work on it. Then from 10 o'clock until 11:55, or however long it takes, I will go over and I will do the pretest for you. There will be either 2 problems or there will be 3 problems on there. Finally, 1 week from today, when your work for 6 and 7 is due, we will have the actual hands-on test. I will again send it out around 8 a.m. It will be due that evening by 11:59 and 59 seconds. Now, all that was a hell of a lot to go over today. All right, I get it. All right. Not only that, as we get going, believe it or not, the stuff that we're going over is going to get harder. All right. Tomorrow, again, we will be going over this chapter, how to handle exceptions and validate data. What I'm going to do for tomorrow is I'm going to add exception handling and validation. I've pretty much got the validation in what I've shown you so far. So we'll go over that again, but I'm going to add exception handling to the programs that I showed you today so that you can see that. So with all of that said, does anyone have any questions on either A, Chapter 6, or B, the schedule that I went over, or C, any homework or labs that's going to be due, or D, any due dates? Anything? All right, then I will be on tomorrow at 8 a.m. I will see you then. Have a good rest of the day.